Yeah. Yeah, you will get the notes. We will send the notes, everything. Okay, up to now, clear? Up to now, everything clear? Okay. Now, the symbol of the element is hydrogen. Hydrogen atomic number A value, we are writing as a 1. Neutron is 1, but number of neutrons in element. Only this question they will ask. Most of the having hydrogen having only itself we are calling as a proton. Other element, if you take 118 element, remaining 117 element having the neutron, but only the proton is exist. So that's next. Next that I written. So A is a mass, means a proton and a neutron exist in the nucleus. So that's why we are saying nucleus mass means one proton, which is equal to 1835 weighing machine. One side if you keep one proton, and the next side you should keep 1835 electron. Then only one proton is equal. So that's electron mass. So with the electron mass, there is no much difference. That means atomic number of the proton exists in the atom. Why I'm saying why we are considering the proton means proton should not change any element. 118 elements are there, means 118 elements having different number of the proton. It should not be similar proton. There is no any element with the similar proton. So that's why we have. Next, hydrogen is atomic number 2, but mass number 4, number 7. Next, 8, and next is 11, 12, and next 14. And atomic number 8, mass number it is 16. Actually, I don't know Hindi. Sorry, I can't able to use the Hindi. Next, oxygen, fluorine, atomic number 19. Next, mass number 20. This we can able to remember the atomic number because order wise first element, second element, third element, fourth element. If we'll remember, we can able to understand. How we can difficult no, then how I can remember. So here C. How to identify mass number? Again, I need to repeat. How to identify the mass number? See here, X element, this is element. X means element. How we can identify the mass? For example, hydrogen is a mass. Here only one proton, 0 neutron. Mass number 4, 2 neutron. Atomic number 4 neutron. How we should remember that atomic mass? So how we can remember? For a simple math, even number. For example, hydrogen. Next one is that this is a even number. And odd number 2, also number is odd number, add 1. If you build with any other element, you have to will be there. I'll tell you that. First hydrogen, atomic number 2. Next lithium, atomic number 4. Next carbon, atomic number 6. Next nitrogen, number 8. Next fluorine, number 10. Now this is even number. Here even number, and this also even number. So 2 plus 2, then which is equal to 4. So helium you are taking. Beryllium means here at multiple with 2. Multiple with 2, then it will become 8. That is atomic number of the atomic. You have to multiple with 2, then it's an atomic number 8. Your atomic number will become 20. Okay, this one we know. So atomic mass easily we can understand. Hydrogen is a exception case. Hydrogen and nitrogen. Remaining everything, whatever I say is equal to 1. You should not multiple with 2, or you should not add. Here 3, you have to you are adding 1, then it becomes 7. So atomic mass of the lithium is 7. With the 2, 5 into become 11. Next year, so 7 into 1. Next 18. So atomic mass of the fluorine is 18. So just this one, you know that. First 10 element, you can able to understand easily. Next 8 element. How it is next 8 element? Sodium. Next beryllium, magnesium. Next phosphorus. Next argon. 10th element. Magnesium 12th element. 14th, 16th, 18th element. Okay. So now it becomes 22 plus 1 equal to 20. You have to multiple with 2. Then it will become 24. 2. Then it become 26. 26 silicon. So 48. Next phosphorus 15. You have to multiple with 2. 30 plus 1, 16. You have to multiple with 2. Then it becomes in here. This is somewhat different case. 34 you will get. 34 plus 1, 35 you will get. But 0.5. That means 0.5 only the variation. Here, chlorine, whenever you are writing the atomic mass of the chlorine, 35.5. Next case is argon, 18 will become 36. Hello?
Sir, chlorine.
What's up?
Sir, chlorine का सर रिपीट एक बार सर.
Chlorine, repeater.
हाँ सर, 35.5 वाला सर.
Actually, sir, element average atomic mass means one is a 30. In the occurrence, they are collecting 35 as a 25% they are collecting. When you are calculating the average, when they will 35.5.
30.
And we can ask a question, sir. Actually, atomic mass means before you said number of the proton and the number of the neutron. Number of the proton should not be fractional value. Number of the neutron should not be fractional value. It should be 1 or 0. If it is a neutron will be there, then we can consider as a 1 or 2 or 3 or 4 or. But if it is a neutron not there or a proton alone is there, then we'll consider everything. Anyway, it should not be fractional value. Then now we are writing the fractional value means because of this reason only. The occurrence in the earth crust, how we are collecting the chlorine and how much different isotopes are there. So chlorine atomic mass and third proton, remaining neutron. Okay, two types of isotope we are collecting. We are collecting in the atmosphere. In the 37 isotope, we are collecting as a 25%. Then overall 0.5. So that's why I said here 35.5. That is the reason. Clear?
Yes, sir. Clear.
Okay.
Sir.
Yes.
Sir, for nitrogen, we are not adding 1 here in nitrogen.
Actually, nitrogen nitric mass 14 and nitrogen first isotope. This one is a 19. This 10% it won't affect my percentage abundance N14. So we are considering as N14 as a nitrogen atomic mass. Even mass is 16.02. It will be there. Okay. So after the decimal, it will be 0.002. No, that's why we are not considering this 0.2. We are considering only the 16 atomic mass of oxygen. So that's the reason we are writing. Yeah, for remembering purpose, I'm saying everything. But if you want to go depth, then it will be different deviations will be there. So this much enough for us first in the beginning. Then after, if we'll understand everything, then we'll go further step by step. Clear now, sir? Clear? Again, I'm repeating. Atomic mass. You have to write the element X, A to Z, and Z is a down left side. Okay, so A, which is equal to P plus N, and N is nothing but neutron. Mass is nothing but atomic mass. We are not considering the electron mass. If they will ask the question, why we are not considering the electron mass? Why? Because atom consists of and neutron. These three particles are there. I said that answer. One proton which is equal to mass. So that's why we are not taking only the proton and the neutron. So that's the reason I said before only. And the atomic number. So up to 18 element compulsory. If people have to remember, then only we can go with each and everything. Otherwise, we can't. And next, why? Because assume the group. What are the groups and what is the electronic configuration? Everything we can understand. Clear now, sir? Clear?
Yes, sir.
Shall I go next? Atomic mass. Atomic number means what? Atomic mass means how we can write up to 18 elements. We can easily understand. Correct? Electronic configuration. Next step. First two groups are called D black. This two series is a F black. Why, sir? Why we are writing S black, P black, D black, and F black? The reason, when you are writing the electronic configuration means first, second shell, third shell. Okay. So now, how we are writing the electronic configuration? Electronic configuration is nothing but number of electrons present in the particular shell. How the electrons are arranged in the shell wise. The first, if you take the first element, I'll take the hydrogen. So nucleus with one shell. Next one is a helium. Nucleus with next lithium. Next carbon, nitrogen, and oxygen and fluorine. And next here nucleus with here also nucleus with a two shell. This also two shell. K. This one is shell name is a K. K is nothing but 1. Here K is nothing but 1. So 1 means only one. And next one is a subshell. What is that shell and what is a subshell? Shell means n value, that is a shell. E subshell, D subshell, F subshell. Why? Because we have the 4 black elements. So that's why we are writing S, P, D, and F. This is subshell. Here, only one shell is there. One shell having cell, which is having one subshell. Subshell means from this division. From here division, how the is first electron it will revolve like this, second electron it will revolve like this. First electron, and the probability of finding the electron in the particular region, how many electrons are located. The probability of finding the region is a K region. In the K region, how many electrons are present? 2 electrons are. That's why maximum occupation of the K shell is a 2. So that's the reason we are writing 1. That is first shell. And which subshell? Only one subshell is there. That is electrons are there. Only one electron. So the electronic configuration of hydrogen is 1s power 1. Next, helium. The electronically S subshell. How many electrons are there? 2 electrons are there. Then electronic configuration of helium is 1s2. Next, lithium. Lithium having 2 shell. One is the K shell numerical value is 1, so 1s. L shell numerical value is a 2. Then second shell means 2 subshell should be there, and the second subshell name is called 2p subshell. First subshell S subshell, second subshell P subshell. Now we have the atomic number of lithium is a 3. If done, how much electron? 3 electrons we have. Yes, they will ask for first 18 element only. They can ask. Yeah, they will ask first 18 element only. Maximum. Only first 18 element only they will ask. Why? Because maximum number of the question will cover with 18 element. So your portion according to your syllabus, only 18 element. Beyond the 18 element, they won't ask. Some special elements are there. Later I'll say that what are the elements it will be there. That element I'll say. Next year, lithium, number of the electron, 3 electron. So first shell it accommodate 2 electron. So that's why first shell 2 electron. In the second shell, it can accommodate 2 electron, overall 8 electron. This electron, only I have the 1 more electron. So then electronic configuration of the lithium, we are writing 1s. Atomic number 4. Here atomic number 4, the first shell name is called a K shell, and second shell name is called a L shell. The P or not, we should not write. Why? Because there is no any electron. So if electron will be there, you have to represent. Otherwise, you don't need to represent. Here next 2s 2 electron. Why I written here 1s 2 electron means it can accommodate only the 2 electron. So that's the reason here I written 2 electron. Anyway, I have only 4 electrons, so that 2s 2 electron. You have to write 1s 2 ps2. Next, if you want to write a neon atomic number 10. I'm going directly neon. So neon atomic number is 1s. Second one is, why? Because 2 shells are there, 2s and 2p. Why? Because 2s subshell in the L shell. So that's why we written 2s and 2p. Here 2 electron and here 2 electron. Here writing 6 electron. So here itself you can remember S subshell will accommodate 2 electron, P subshell 10 electron, and F shell accommodate 14 electron. Okay. Then how it is 14 electrons, sir? How it is 14 electron? How it is 10 electron and 6 electron and all? 3 bucks. And D 5 bucks. And F 7 bucks. Overall 7 bucks. Each box it will accommodate 2. This one I said no. So each one is a first electron and a second electron. First electron, second electron, and 6th electron. Here same as it is. First 5th electron, again 6th electron, 7th electron, 8th electron, and 9 and 10. So 14 electron it can accommodate. So when you are writing the electronic configuration, you should remember how many electron it can accommodate. And a different element. For a different element means, so for example, chlorine they give. Then how we have to write the electronic configuration. Next, same method only should follow. What is the same method? The first period element. Everybody knows the chlorine located in the third period. K shell. Next one is a L shell. 1. So 1 subshell. L shell numerical value 3. Then 3 subshell will be there. Overall 3 subshell. Now K only 1 subshell. S and 2p. Why I written 2s and 2p means? So that's why I written separate 3p and 3d. 17. That means number of. Why? Because on the chlorine center, I didn't write any plus or minus. If it is not there plus or minus, then number of write the electronic configuration. Then we can write the electronic configuration. The first one, 1s is having only 1 box. 3s only 1 box. 1, 2, 3 box. And P here P. Next D orbital. D orbital will start from question. S orbital from which shell onwards will start. S orbital it will start. That means onwards it will start. L in the shell onwards. D subshell will start from the third shell onwards. So D subshell it won't exist in the second shell or first shell. And the same thing P subshell it won't exist in the K shell. That means in the electron overall I have 17 electrons. So first electron to a second electron. Remaining I have 13 electrons. Here 1, 2, 3, 4, 5, 6. Overall 7 electrons. So here 1 electron, here 2 electrons. So 2 electrons over. Remaining I have how much? 5 electrons are there. So from the 7, 2 electrons. And next fourth one, fifth one, the third electron, fourth electron. Next fifth electron. So we can write the electronic configuration 1s, 2 electron, 6 electron, 3s, 2 electron, 3p. It is only 5 electron. It is not 6 electron. It's not 6 electron, only 5. So this is the electronic configuration of the chlorine element. Suppose if they will ask the question, write the chlorine minus. What is the electronic configuration of Cl minus? If they will ask the question, then now we can write the first one. 1s. Why? Because 17. That means number of the proton. Minus is not minus. It is indicate electron charge. Okay. Then number of electron increased. How many electron increased? Only 1 minus they give. Then 1 electron increased. Then number of the electron 17 plus overall number of the electron is 18. Then how we can write the electronic configuration? C electron 2, 3p 6 electron. This is the electronic configuration of Cl minus. Okay. Understand? Next question. If they will ask a question, Na number 11. Why atomic number 11? This is the 11th element. And this element where it exists in the third period. One is a K shell, another one is a L shell, and another one is a M shell. And number of the proton equal to 11, and number of electron which is equal to 11. Why? Because it's a neutral atom. So that's the reason. Now electronic configuration you are going to arrange. K shell numerical value, M shell numerical value 3. That means K shell 1. That means only one subshell should be there. L shell is a second shell. Then it is, and next M shell. How many subshell will be there? 3 subshell. S, P, and D. This number 1 you have to keep here. 1s. This number you should keep here. Next this number you have to. Next this number. Next this one is a 11. So 11 means yes, subshell will up one. It can accommodate only 2 electrons. 2 return. And here you can return 6. Going to write here overall number of the electron. Here 1. Then what is the electronic configuration? 11, 1s, 2, 3s, 1. Okay. So this is Na plus what is the electronic configuration. Then we should identify the how many number of the electrons. This is here they given plus. If they will give plus, you should neglect. Should do. If they will give minus, you should add. If they will give plus, you have to subtract. So 11 minus 1. With the electronic configuration, what you will write? 1s, 2, 2s, 2, 2p, 6. This is electronic configuration. Clear? Understand?
Yes, sir.
Okay. From this, any doubt? If you have any groups are S black, and the last 6 groups are called the S black. This is a P black. This is a D black. For example, hydrogen. No. So hydrogen you written as the first element. The last electron where it is entered. So lithium. Hydrogen, lithium. Next sodium. It will go like this. So now hydrogen atomic number 1. Electronic configuration. What we will write? First shell number 3. It's having 2 shell. Then 1s you are going to write. Atomic number 11. Then now we can write 1s, 2, 2s, 1. See now, hydrogen S subshell. Lithium, the last electron. Sodium, the last electron entering the S subshell. That's why we are calling these elements are S black element. If the element entered in the S subshell, then we are calling S black element. If the last electron entered in the P subshell, then we are calling as a P black element. If the last element entered in the D subshell, then it is D black element. The last electron entered in the F subshell, then it is called the F black element. Clear? So black wise, we can say that. So based on the electronic configuration only, they are arranged. Okay. This modern periodic table given by the mostly is modern thing is that there's no any drawback. It is everything perfect, but only one drawback, one other drawback. Why sir hydrogen is one other drawback? Why? Because that element. Why hydrogen is a drawback of the modern periodic table? The first case, here observe the color of the non-metal is a non-metal. Okay, and S black, D black completely metals. There is no any non-metal. But even though how they kept the height S black and the 2 in metal series. Okay, it is one of the drawback and also advantage. Why? Because mostly arranged based on the electronic configuration. So how the electronic configuration of the element. Next one, and lithium, potassium, 4s1. So that's the reason they kept hydrogen as the first element in the periodic table. That too in the metal, where we 4 different blacks: S black, P black, and D black, F black, and the first from this element completely metals. it is completely metals. Next, in this p black element having 3 division. One is a metal and another one is a non-metalloid. That means semi-metal. Why we are calling semi-metal means is a catalyst. Okay, like we are calling male, female, transgender. So same as it is metal, non-metal, and semi-metals. This is a border. The perfect line, it is a metallite. This line only metallite. Some elements, overall 8 elements are there. Metal, non-metal, metallites. You have any doubt from this? Yes, black. And they'll ask a question: D black, everything metal. P black and metallite, and semi-metal or metallite. Next case, they will ask one question. Only one period exists 3 types of element, 3 nature of element. Which group? So see here, this is a 17th group. Either they can say that 17th group in the Roman letter, this 2 groups subgroup, and this 10 groups are B subgroup. Outside as a A subgroup, B subgroup. In the Mandeli periodic table, they kept like that. So that's here. This is first group. So first group means 1 A. What's up? Hello? Yeah, noble gases also non-metals. Even noble gas also we are calling as a non-metal. What's up? Hello? Is there any doubt? Okay, next is a group, A subgroup. First one, 1A. Then this is 2A. Next year, 14th group 4A and 15th group 5A. The last one group in the Mandeli periodic table element. So that's the reason they could not arrange the element in the Mandeli periodic table. So in the Mandeli he didn't give the position of the element. So that's why we are calling as a 0 group element. Last noble gases that time they didn't find the element. So that's the reason here last we are giving B group. Next year 3B. Next cobalt and nickel. This together they will call as a 8B. Overall 18 group. If you will give the number 1A, 2A, 3A, 4, sorry, 1, 2, 3, 4, 5, 6, like 18, you can keep as a rare element or up to rare element, up to noble gas. Okay. Next one, valency. What is mean by valency? Of an element. Valency, combining capacity of an element. So for how many element it will attach with the bond? How many bond? How many valency? Okay, just having only one valency. There is no, it is valency 2. And next year, this D group element we can do 8. We can write 8 valency, and maximum 7, maximum 8 will be there. It will show all the element. It won't show. Here first group element will be valency 1. This third group element, everything is a valence. Next again it will reduce 1. Again it will be reduced. It will become 0. Why we written 3, 2, 1, 0? Okay, the reason 1 also 2. Here valency also 4. Here valence electron 5. Can accept 3 electron, or it can donate 5 electron. So donating a 5 electron is not easy. Accepting of 3 electron is easy. Why? Because when gas configuration, for example, chlorine I'm writing atomic number 9, 2s2. Next 2p 5. So overall next overall atomic number is 17. So yes, 2p. That means if you want to complete the shell, 8 is 7 electron. That's why we need one more electron. So the chlorine oxidation number. Oxidation. If without a sign, if you say that is a valency. Overall 7 electrons are there. One more electron configuration. If it is chlorine, will noble gas. Argon is a noble gas. Then if it is become noble gas, then almost the element will be stable. That's the reason it's going to accept or donate or share. So 3 possibilities. Every element other than the noble gas, every element will involve the bonding. Every element unstable. So because attain the stability. Okay. So the element going to attain the stability means 3 ways it should follow. The first way is the donation of electron. If it is metal, the element, if it is metal, then it will donate. If the element is non-metal, it will accept. If the metal is non-metal, okay, but the electron pulling nature is very less, or electron donating nature will be very less, then at the particular time, it will go under the sharing of electron. For example, carbon and all, it won't donate the electron, it won't accept the electron. it will share the electron with one atom with another atom, sharing of electron. So three possibilities. So first you should remember, first group has already the K shell becomes stable. If I'll remove the second shell electron, then K shell becomes stable. Then the atom it will become like a neon configuration. Then it is more stable. So that's the reason we are saying if it is a loose electron, or otherwise if it is gain the electron, how many electron need to gain? To gain 7 electron. It will gain 7 electron is not easy, and the nucleus, the proton cannot able to control the electron. So that's the reason is a easy method to remove the electron. So metals, it will metal is going to gain the electron. Here also up to +3. Next, either plus or minus. The 4 valence, So either it can lose electron, or it can gain the electron, or it can share the electron. Three possibility it will follow. Next, nitrogen. If you go nitrogen state, it can accept 3 electron. And if you will go to the second last means it will accept 2 electron. So that's the reason -2. Oxidation state -2, valency 2, and chlorine valency 1. Last, already noble gas. No need to gain the electron, or no need to accept the electron. Okay, no need to accept the electron, or no need to send the electron. So that's the reason we are saying. That's the reason we are saying this one is a zero group element, or it won't combine with any other element, any other atom. Okay, this one understand, no?
Yes, sir.
Okay. The 17th group, why it is highly active means it's need only 1 electron. So when it gain the 1 electron, it will be more stable. So that's the reason the 17th group is more reactive nature, and it is highly reactive nature. So that's the reason I said that 17th group highly reactive. Even first group is highly reactive. First, this here also will ready to lose electron, and this element is ready to accept the electron. So that's the reason these two elements are highly reactive nature. For example, sodium, if you take in atmosphere, without in kerosene, we should keep inside the kerosene or a paraffin wax. Otherwise, the sodium, if you'll take outside, automatically it will catch the fire. So that's the reason it will make the accidental fire. Even if you throw sodium atom with water, suddenly it will catch the fire. It will burst. So why? Because sodium is a highly reactive nature. It won't be stable in our atmospheric condition. We are thinking about only our atmospheric condition. 25 degrees Celsius, 1 atm pressure, whether the substance is stable or not. If it is stable, we are saying stable. If it is not stable, then it is unstable. Why it is unstable? Why? Because why it is unstable means it is not completely stable. It is not occurring the noble gas configuration. That's why it is unstable. Then when it become unstable, when it becomes stable, when it will involve with other element bonding, or when it become noble gas configuration, then automatically it will become stable. So that's the reason we are saying. Okay. And one question I asked nature, bromine is a liquid. Most of the competitive exam, they will ask the question in the periodic table, under overall 18 periodic table, 18 groups are there. In the 18 group, only one group having 3 different nature of the element, gas, as well as solid, as well as liquid. So in the non-metal, if they'll ask the question, in non-metal, what are the elements are liquid? Bromine only the liquid. In metal, what are the elements are liquid? Mercury only the liquid. Okay, in metal, mercury, non-metal, bromine. Okay, this one you should remember. And 17th group is 17th group having 3 different nature of the element. So first element, first 2 elements are gaseous nature. Next, bromine is a liquid nature, and the remaining elements are solid nature. Acetylene we won't consider. Why? Because acetylene is a radioactive element. The lifetime will be very short, so we won't consider. Okay, this one you have to remember. And next, what is electronegative and electropositive? An element, you are 3 fundamental particles. Now, in the center of the nucleus, 2 fundamental particles are there, and electrons are surrounded by the nucleus. This is electron. Electrons are electrically positive, negative, and neutrons are electrically neutral. That means the charge will be 0, but mass is there. Charge will be 0. Okay, so we know this. Next case, electronegativity. What is meant by electronegativity? That means when I is going to decrease, the size of that is the size of atom going to increase. Already charge will be of the radius is increased to going to limit compared to equal to group A, it will increase complete size up to compared to 17 8. So this one of that last period is essential. Actually, clear, understand this one. Next of that,
Sir, please.
then yes, what is the doubt? Is there any doubt? Hello, anybody having doubt? Okay, so now the size of the atom increasing from right side to 7 is again 18. Whether the electron, the size of the atom will continuously decrease or not, or first it will decrease, after it will again is going to increase or not. So this question they'll ask. You have to remember that from 1 to 17 size decreasing, and 17 18th group again electronegativity. Electronegativity same as it is size. If the size particular with the En. En means electron pulling nature of the nucleus. Okay, how much this group? 0. Why, sir, it is 0 means it won't have any electron. Already know that it won't accept the electron, it won't donate the electron. Then electronegativity automatically it will become 0. This group. Next one, from year to year, from top, cesium negativity 4.0. Cesium having electronegativity value. You should remember only two values. Electronegativity. Okay, in the 118 element, fluorine cesium is the lowest electron. If it is highest value, is the electronegative value to metal. That means if it is electronegative value more, the element act as a non-metal. If the electronegativity is very less, then the metal will act as a the element act as a metal. Okay, so this one you should remember. And one more case we can say that cesium we took size. Okay, why we selected cesium? Why not francium? Only the lower francium and that means the lifetime will be very short. Within the fraction of second is going to decompose. So that's the reason. So that's why I said cesium electronegative value. Cesium is the lowest electronegative 4.0 and the cesium electronegative value 0.7. Okay, next one more thing. Here 4 and the next element. You are writing fluorine here, and chlorine next to bromine. Fluorine 3 point. You should write 3.0. This are year to year decreasing, and year to year increasing electronegative value. This much will complete today, and remaining part we will discuss in next class. Okay, if you have any doubt regarding this concept or any concern, you can text the message. Okay, fine. In the what? Okay, and already they posted in the group some questions they posted, and try to solve the question. If it is you could not able to solve the question, then ask as a doubt, then we will clarify the doubt. Okay, sir.